So in this video, we're going to talk about gas and the kinetic molecular theory. And on the kinetic molecular theory is basically a group of assumptions that explains the behavior of gas. All right, and when a gas actually obeys all the assumptions, then we say that this gas is ideal, or we call it an ideal gas. All right, so we're just going to go through each of the assumptions and kind of talk about them and describe them in some more details about, and so that way we could recognize when a particular substance or when a particular gas is acting ideal. Okay. So the first assumption is that the gas consists of particles moving at random with no attractive forces between them. All right. And so this gas has to be moving at just any random motion. Nothing's controlling them. And they cannot have any attractive forces between them. In other words, there should be no intermolecular forces between these particles. All right. There's no attraction forces. There's no repulsion forces. And the particles are able to move in complete random motion, not affected by anything. All right, so that's the first assumption. So the second assumption is that the amount of space occupied by the gas particles themselves is much smaller than the amount of space between the particles. So this really means two things. One, that the particles are very, very small. All right, so very small particles, very small gas particles particularly. And then secondly is that most of the volume of the gas, so most of the space that's taken up by the gas is really just empty space. All right, and so we have very low density. And so it allows for compression, it allows for pressure changes in this case. But all this is really saying that the particles are very, very small and then that the density is very, very low. All right. So the gas takes up a lot of space and the space is mostly just filled with, it's just empty. There's nothing really there. All right. So that's the second assumption. The third assumption is that the average kinetic energy of gas particles is proportional to the Kelvin temperature. And so when we're talking about kinetic energy, so here is basically saying that the amount of kinetic energy that's found within a gas particle is completely proportional to its temperature. Remember, temperature is the measurement of random motions of any type of substance, or we could say, in a sense, how much energy does it really have? Okay. And so when we're talking about Kelvin temperature, then the kinetic energy of those particles has to be essentially proportional to its temperature and cannot be caused by anything else or any other outside factor. All right. And so if the gas, has a temperature of, let's just say 300 Kelvin, then the amount of energy that it contains, or kinetic energy contains, should be proportional to the temperature itself. And the last assumption is that the collisions of gas particles, either with other particles or the wall of the container, are elastic. That is, that the total kinetic energy of the particles is constant. So this simply means that if gas particles were ready to collide with one another, or it hits against the container wall, or wherever it hits something, that when they bounce back, they still have the same amount of kinetic energy as if before they bounce one another. All right, so it's kind of like different from like a car accident where, depending on, the hit itself or the impact, the collision, there is a certain amount of force that's been exerted. And things are flying different directions and at different speeds. But in this case, what it's saying is that, if you have a molecule that hits another molecule at 75 miles per hour and it bounces off, it will still continue going at 75 miles per hour. All right. And so the amount of total kinetic energy of the particles remains constant. Nothing's changed. Thus, or it's elastic. Okay. And so now, as I was saying earlier, is that when you have a substance that that actually agrees to all four or obeys to all the assumptions, then we say that this gas, all right, is an ideal gas. All right. Now, ideal gas allows us to predict many different things. It allows us to help us calculate many different aspects of the gas for scientific purposes. In later videos, we're going to actually look into what are those aspects and how we go about calculating them.